So what starts tomorrow? Class enrollment. So those of you that need to go find classes and get those nasty advisor holds off your account, please do so you get enrolled. It helps us know what we need to do in the spring, if we need to add additional sections, whether we cancel classes. And sometimes it may be a course you need to graduate, so getting it canceled because people don't enroll. And I would like to think that we're all really responsible. I've had a ton of people asking about questions and different comments, so make sure you do that. We have added some different sections, so look through and make sure you're looking at them. Have a plan. Graduating is kind of the goal, I hope. Now, graduating means you have to get the big girl or boy job, and then that's kind of a horrible thing. So we have I know for some of you kind of a short week because we're gone part of next week, and some of you are on a trip that are in the here. So we're going to go through a piece of this, and I want to work on some of the homework in class and hopefully show what we're looking at. So this is really the idea. We're talking about now that network management piece. So we've talked about how it's built. We've talked about some of the components, and now we want to look at how do we manage it for example, on a day-to-day basis. What can we do to make sure that things are working like we think they should work? And why do we care? Is this an expensive venture? In some cases, it can be. If you have 100 people and they suddenly can't get onto a network share and they can't do their job, or they lose VoIP phone service and they can't use their phones, it can be very expensive. Think about if Blackboard went down, what it would do to something like a college, how we would deal with that. So we want to look at some of these topics, and one of them we want to do is we really want to be as proactive rather than reactive. Because up to this point we said, we need to fix the network or fix these pieces on our system, but now we're looking at, can we be proactive and even prevent issues before they occur? So if we can do that, within cost reason, it's actually a very good thing to do. So downtime is expensive. Downtime can lead to productivity loss. And around here, for example, if you're in a smaller area, once you have an issue and it breaks down, then you have to troubleshoot, figure out what happened. And getting somebody down into the Auburn area, for example, it's pretty pricey. There's not a lot of local resources in some cases. So how do I bring resources down, and how do I start working with them? So one of the things we like to do is have something about a baseline on our network. So in other words, we've evaluated it. And so those of you that are athletes, you do the same thing. You do a baseline on your performance. And you say, okay, I know that normally I can bench press 240 pounds, but I don't do that every day. I maybe do 70% of that. And if suddenly that's hard, we know that something has changed in our performance. Or if suddenly that 240 pounds is really easy, then maybe our strength's increased. In other words, we need to do another baseline. Well, the same way with our network. So I'll flip ahead to this one. So this is actually a baseline measurement. So this is daily traffic, and this is how much data is being consumed on each day. So most businesses, you end up paying for that traffic, and we can look at it, and we can say, okay, we bought a 50 gigabit package. Is this appropriately sized? Well, in this case, it looks like it probably is, but there are days, and when we look at these, you can see some cyclical patterns, and you'll start to see that. You'll see, oh, on Friday, we start having more data spikes, and during the week. During Sunday, not a whole lot of traffic, but we can start to look at that, and maybe it starts telling us, in order to maintain our performance, we need to increase our bandwidth in the future if our trends are moving up. So these are all tools we can look at. So things we might want to look at. Well, who's all logged into our network? At what times? Not only can we do this from that baseline, but it's really a good idea in terms of a security point. who's logged in, how many people are logged in. We might look at things like if we run Wireshark and we start pulling data out of a switch, we might look at what kind of errors are we seeing. Do we see errors increasing? What applications are users doing? What kind of software? Because today's software, so it used to be your software set on your computer and it would go to the network and it would get a file maybe. But now we're pushing out more and more data over that network all the time. So we're using those Web 2.0 applications. You're using online applications. So we're sending more and more data. We're doing more and more video. So maybe we need to change some policies even about what people can do on their machines or what software we're using. And these can be a tool where we can say, you know what? We used to have a network and it worked really fine. This is what happened. We have more people using it. Maybe we doubled our number of users. Our bandwidth is increased. We need a way to increase that bandwidth. And that's certainly what we do here at the college. We look at these things in terms of what are students doing, what are our faculty doing, what are staff doing, and we try to size this appropriately because internet is expensive. Internet connections are expensive on a business scale. And so when we have to pay for all that traffic, we maybe have to think about how do we deal with it. But this gives us that this is what we normally should expect, and then we can also look at what's going to happen. So we also look ahead, and this is where it gets a little tricky. But we know in general that usage is going to go up as more tools. So if we change things like MyPSC, where it used to sit locally, and now it sits in Omaha and UNL. Now when we move data in and out of that, we know that traffic is going to increase. We think more users are going to send more data. How do we deal with that? So there's a lot of applications out there. So everything from SolarWinds and some very expensive ones to there's freeware and there's different pieces that we can get that will let us generate that baseline data. Well, we're cheap, so we're going to show you some free ones and look at that. But there are some very nice, very expensive, very user-friendly. So one of the ways we can control this is through policies. But the same policies and rules also provide us with some controls. And so here, we don't necessarily have HIPAA as much, although we do have some insurance records. So think about over in the student center over there when they have the doctors, nurses, those kinds of things coming in. We also maintain some records of your personal health. So for example, if you're an international student, you have to do TB testing and all kinds of things. And I think, does everybody still have to do a TB test? You guys are looking at me like I'm crazy, so I'm apparently not. When I went here 15 years ago, all students had to do a TB test. So those are medical records that are stored somewhere on our campus. So we might fall under that. But we certainly fall under what's called FERPA, the Federal Educational Rights Privacy Act. And it says, all right, these are things that your student data has to be protected, how it has to be protected in some cases. And if you look through, there's a whole ton of those. One of them that affects us, the PCI rules. So the payment credit card industry. How many of you paid cash for your tuition? Wrote a check? A couple of you? How many of you paid on some kind of a card? Debit card, Visa card? Yeah. We use that a lot. So if I go pay my traffic ticket, which I see is now listed finally in MyPSC, I'm going to do it online and use a credit card or a debit card. And so those rules are created and they require some things. So for example, PCI requires an audit every year. And some of the things it requires are how your network security has to meet a certain level. Your physical security has to meet a level. And one of them, because of our design of our building that I know they have gotten dinged on before, is they don't have a person trap or a man trap, as it's called. So in other words, there's not a two entryway into the little tiny server closet. Somebody can just open the door and they're in there. There's no way to trap them if they don't belong in there. We don't do a lot of biometrics here yet. So some of the rules we have to do something else about. We can't meet all of PCI's rules. So when you go to pay for something on our campus, do we actually process that card directly? No, we send it out to a third-party processor who can meet all of PCI's rules. So some of these aren't laws, some of them are. So HIPAA, for example, has some teeth. If you're in the medical field and you lose patient records or you violate HIPAA in some other ways, there's some pretty big teeth to it. $50,000 fines. And it's not just to the company. You can actually be personally fined for some of these HIPAA and FERPA violations. So if I logged into our systems and somehow I managed to get everybody's Social Security number and I went out and posted it on my personal website, I can be personally fined, and that would not be very pleasant. So these are practices, in a lot of cases, best practices, some way we can set up our network in the best way we can. So one of the things we want to do is look at an ongoing or continuous, or in some cases maybe because we don't want to impact network performance, we test on a weekly basis, but some way that we're monitoring on a continuous basis. So we set our baseline, we know where we're at today. How do we continue to manage it? And then now a lot of the devices are getting smarter. So our switches are getting smarter. Our routers are getting smarter. Our firewalls are getting smarter. And so in a lot of cases, when they have some kind of an issue or a fault, they can actually now page us, send us a text message, email us, and they can say, hey, I'm getting too hot. So we can put in sensors in our data closet to monitor that temperature. Devices themselves, when they start to fail, if we can do that. We can have a device that says, all right, I've got something that's failing. A lot of times they have redundant components, so it'll send an email and say, hey, hard drive 37 failed. Please replace me as soon as possible. But I'm still able to operate because we have those redundancies built into our network. So SNMP, Simple Network Management Protocol. So this is really another language that all these devices can communicate. And so SNMP then gives us the ability to grab data from all these different devices, not only manage it, but also get performance data. And so we can easily then, in theory, easily monitor all these network devices. Now, I will say that there are some companies, Cisco, that don't always cooperate and play very nicely, but we can actually monitor a ton of devices with this software. And so we'll look at a version of something that uses that. So SNMP, there's a couple different versions of it, but what it's really doing then is we have a server or a piece of a server running somewhere. And so now all these things from laptops, desktops, printers, everything's communicating back, and they can detail a lot of different pieces. So is my toner low on the printer? Is my switch overheating? Is the phone system got some kind of an issue? So it's a control and a data collection interface both. So it can actually send data both ways. So those logs out of there, and one of the recommendations every security firm is always going to tell you is go through all your system logs and look for anomalies. Well, the problem with this, who has time to do that? Most IT staffs, somewhere like here, they're overworked, underpaid, understaffed. So now there are some tools where we can automate that reading of these logs, and they can look for, and they will do a better job in some cases than humans, because they're trying to spot those out of bound, out of network, out of spec types of things. So we can look and look at what's going on in there. So we have a whole ton of logs. Even on your own computer, every Windows machine has a ton of logs we can get to, and we simply can get to that by going Event Viewer. And so on our own machine, if I click the Windows button and I type Event Viewer, and I'm sure it's going to pop up in the wrong window for me. Oh, it actually popped up in the right one. So on our own computer, much like on the server, there is everything that this computer does. So if I go into application logs or Windows logs, I can see details of every application that's run, security issues, setup, system. And so in this one, I see I've got some errors. So the Kerberos client received an error, etc., etc., etc. So that's a system log, setup, security has its own area. And these are all setting right in your Windows machine. So if we do have an issue, this is another area we often go to. So those servers on these different web network applications are all sending in all this data. So we're churning tons of data. What do we do with it? So our servers have logs just like that event viewer. And so Linux has them in a slightly different location. And so it depends on how old or what version. But if you're administering a Linux server, you should know where those are at. That's one thing we should always do. Make sure where those logs are, because when we do have an issue, this is where we go. If we have a hack on our system, guess what the FBI, if they get involved in it, are going to want? Hey, can we have copies of all your server logs? Because it details all those connections and all those attempts. So we have those tools, but not built in usually. Not built in usually. We need some kind of traffic analysis. And so there's a couple of different ways we can look at it. So a network monitor monitors the entire network. And so depending on how it's set up, we can put little agents on various devices. So maybe we put agents on all of our switches. Or we can look at a single interface. And we can do the same thing on our own computer. We can look at a single device. So if I go to Task Manager, so load over here. So on this particular machine, I can actually monitor some traffic. So I can go to the Performance tab. And I can monitor a couple of different pieces. In this case, we're looking at Ethernet traffic. And so if I get the right interface. So we can see what traffic we're moving here. So this is a single interface. We're not doing a lot with it, but we're looking at that traffic. And we can say, okay, we're receiving, we're sending. And so if I were to open up something that was very chatty, you'd see that traffic spike up. So because I'm going to grab a YouTube video, this video tends to be our most bandwidth intensive. And we'll just grab whatever happens to be on YouTube. I'm going to mute it. And so now, I just started to click a YouTube video. What happened to my traffic? So my received traffic went from 8 or 9 kilobits. Now, and notice as that traffic, it fills the buffer, and it fills the buffer. And so YouTube and some of these can be very problematic on our network. Everybody did that in the room. Suddenly we're seeing that happen repeatedly. So it's kind of interesting that YouTube does that. And you'll see that kind of pattern with a lot of video streaming services. If we watch Netflix, it does kind of the same thing. So you're filling that buffer in your computer with another couple of frames of sound and video, and then it's going away. Fills it again, comes back. Fills it again. So now we've added a traffic load, and we can see that on an individual one. So that's kind of the difference between traffic on a single machine. I can come back over here. So there we're looking at an interface. Now we can set it up a little more sophisticated, but I wanted to just show even on a PC, we have that ability to look at some of these items. And so when we have an issue, a lot of times we'll look at what's going on that network. What is happening on that task manager? Do we have an application that's running a lot? Is it moving things? So this is how we can monitor our entire network. So if I look at a drawing like this is my network. So here's my wireless access point. So here's a router. Here's a switch. So normally, a switch only sends traffic to a computer that's sent directly for it. It says, oh, here's your address. So you only get the mail that goes to your mailbox. When I mirror off a port on a switch, when I do that, I take all the traffic. So if it's a 48-port switch, I take all that 48 ports and I send it to one port on that switch for diagnostics. When I do that, and there's our computer down on the bottom right-hand side, all the traffic on that switch is sent over here, and it goes to this computer so we can monitor it. So it's a good tool. Maybe we do need to monitor all that traffic. But on the other hand, if I've done it on the security side, and I left my switch unsecured and I did this to see what's all on that network, might be a little sneaky. Here we have another one called a network tap device. So in here between the router and the switch, it's grabbing all of that traffic and it's sending it down to this computer and says, hey, send me all your data. And so it's essentially just grabbing everything on that communication from the router to the switch. So in this case, everything going in and out of that network is going to go to that. Sometimes we install those devices and purchase them. And then this is kind of an interesting term. So we look at both wired and wireless cards. We can enable what's called promiscuous mode. Promiscuous mode says, I'm going to take all the traffic I see and I'm going to grab it. Normally your wireless card ignores anything that's not sent directly to it. But in promiscuous mode it says, I don't care what that traffic is, I'm going to grab it and read it. And so in promiscuous mode, a wireless card grabs all of the traffic that it can read off of that access point. And if you're not an encrypted connection, so I'm out here sending data over here somewhere else to that access point, and I'm not encrypted, that laptop with that wireless card setting in promiscuous mode just read every one of my packets that I sent there. Maybe it was nothing. Maybe it was my bank account information. So if I'm not sending data encrypted, bless you, that is an issue. So these are some of the ways we can start snagging that data. So all of them kind of function in some ways very similar. They almost always set that NIC to run in promiscuous mode. And not all network cards will do this. The higher end cards will. Weirdly, the cheap ones won't usually. So they're not capable of handling that much traffic. And so they tend to not be able to do it. So if I buy an Intel card versus a Linksys or something, sometimes we will have that difference. So we want to look at it. They're grabbing frames. They're monitoring. When I say grabbing frames, that sounds like something we've already done, doesn't it? What's a tool we've already used that grabs frames? Wireshark, that packet capture. So it's doing the very similar thing that we've done before. We're gathering traffic. Now, Wireshark doesn't necessarily do it automatically and send us updates and reports, but that's really what we're looking at. So they can also do all kinds of other things. They can set baselines. We can track utilization, trigger alarms. We can look at them and we can say, who is the top talker or top listener? So who's sending and receiving the most data? And we can see some of those pieces on our software already. So if we logged into our router for this particular room, if I can get there, nope, I do want to really log into you. Proceed. So our router in this particular room, so this is another thing we're looking at. In this case, all of the traffic for this room goes through this router here. This particular router actually says, I can tell you a little bit about that. And notice what it's doing. It says, here's my router statistics, how much data I'm sending and transfeeding back and forth. But if I go up here to dashboard, and on the traffic analysis, I can actually see which device in here is sending and receiving the most data. And so in this case, by far the most data in this installation behind that router is this device here. So this one, since we've reset that counter, has sent and received 3.1 gigabytes. Nothing else is even close. What does that number represent on our network, do you think? What is 192.168.180.5? If I type it in your browser, where do you go? So if I type that in my browser, where do I end up? So something about IIS server. Yeah. That's actually that server we use to share your files and control the lab. So that makes some sense. It's got more traffic than anything else. But if I looked at this and I saw one user had more traffic than anybody else, I might want to start drilling down and say, why is John using half the traffic of our network? And so this isn't the most sophisticated tool to do that, but it's one we already have. It's built into this particular router, and most business routers are going to have tools like that built into them. They're able to use that. So now we can say, all right, we got some traffic data. We see where it's going. We looked at anomalies. Now we have a baseline. How do we start proceeding then? These can be useful for tools of saying, for example, so boss, we're maxing out our network utilization. We're maxing out this. We need to expand our network. It could also be a means of, we have bought too much internet. So, other things you may run into. So there's all different kinds of issues. So runts, giant packets are great, but they can present a problem if any part of our network can't pass a giant packet. So is a device resetting? Do we have discarded packets? What kind of packet loss? And so these are tools. If we suddenly have one device that's losing every packet being sent to it, we can probably say, there's something wrong with that device. And so in that case, we'll get an SMS text in some cases or an email, and it will say, hey, there's a problem with computer 147. Well, we also use this for management purposes. And you guys are all, I won't say used to the idea, but you're having it done to your traffic here on our campus, whether you like it or not. So if you're on our campus network, all of your traffic is being shaped. If you're downloading Netflix, you get much less priority than if you're in the administration building connecting to MyPSC. So we look at those individual packets and we can manage traffic. We can also drop traffic that we deem unessential. So if we're at a business and we said, you know what, YouTube is not essential to our business and our employees are wasting too much of our resources doing that, we could actually use traffic shaping to drop YouTube. And actually for a long time, we actually didn't allow YouTube videos on our campus because of the bandwidth issue. Now we've got enough bandwidth that it's not as big an issue. So what we're trying to do then is set up a way we can manage our traffic, get the important traffic. So we prioritize things like VoIP calls, voice over internet protocols. They get the higher priority because if they delay, then you get those weird echoes and your voice doesn't sound right, or you even drop a phone call completely. Whereas if it's an email, if an email arrives 2 seconds late, is anybody going to notice? Probably not. So, ways we can do it. We can delay the less important traffic. We can limit traffic. We can limit it for an interface, so one particular address we can limit it. We can limit it by type. But here's an issue. If I'm an internet service provider, can I get into trouble for doing that? Well, it depends on your agreement with. So Comcast has done it. Time Warner Cable does it. Why would they want to discriminate against certain types of traffic? Why would Comcast or Spectrum or Charter Cable or any of those, why would they want to not send as quick as possible Netflix data to you? Which in that case is one of the things that they have been accused of. You are. So you're costing them money because that traffic isn't free. And in a lot of cases, people were costing Comcast and other companies far more than their $40 or $60 in traffic. Plus, it's a competitor. So they had their own video streaming services that they controlled and monetized. So that traffic shaping, even in a business, can be an issue. Here at the college, I suspect it could be an issue if we were found to be shaping traffic to, in some way, monetize a company. So if we had signed an agreement with Netflix that we would prioritize our traffic, and then along comes Amazon Prime Video and says, we're going to sue you for that, I think that could be an issue. So we need that issue of fairness. We also need to know who our target is. If it's a private company and they say you can't get Netflix on your private network at the company, that's probably not a big issue. But here, if we blocked all of, maybe we decided we're going to block all the porn sites we can possibly break or block. Could that be an issue of equitability? Yeah. Libraries, I know, have come into server of that. So how do we prioritize traffic? Well, we can do it by protocol. In other words, which language it's coming in, what VLAN it's in, its IP address, groups, what the application is. Once we get inside of that packet, we can actually look at it and see what that packet actually contains. And there's some flags in both IPv4 and IPv6 that will allow us to do that. So one of the techniques we use then to monitor this traffic and hopefully speed it up is the idea of caching. So things that are used frequently, we store as close to the user as possible. So with web caching, we only have to download that content once. So it saves us money if we're paying by the gigabyte. So we're storing, for example, the Lincoln Journal Star pages on our campus, and every time you go to Lincoln Journal Star, it says, hey, let me go check the Star. Nope, nothing's updated, and it grabs a local copy of it. Internet service providers. So Spectrum does that. They grab copies of traffic that users go to. So the first person that goes to Journal Star at Spectrum gets it set to that cache. Well, that's a way we lower that amount of our cost because we're pulling that traffic back down. You can get the page a lot quicker because it's closer to you. So, before we get to unified communications, we kind of have to go down a stroll down memory lane. So many, many years ago, we had a phone system, and it was all circuit switched. Every phone call was switched directly somewhere at a switch, and if you go back even further, it was actually done with an operator. And so you may have seen movies where they're showing, calling operator, I need to get a hold of John Smith. So then we automated that, but it was still a switch network. Everything came through somewhere in a switch, and every little town had a central office. Well, what has happened is we realized that we could digitize all this data. And so those phone switches have changed. And now that we break everything into data into packets, nearly all phone calls now in the United States are done via circuit switch or a packet switch technology. In other words, it's digitized, sent over a packet. Well, part of that is cost savings because we can crunch that data down even more. The cost of the switches are significantly less. So one of them I've seen fairly recently was in Fall City. The original switch room for Fall City is about the size of this room, about 25 by 30 feet, 40 feet long. And it was full of switch gear for a town of 4,000 people. Now, the entire town is switched digitally, and the equipment for it would fit in our rack back there. So they took what used to take an entire room, now it's a very small, so just the cost savings in terms of the electrical, the space is significantly less. And so it also gives us some freedom about how we send that data. So in circuit switched, we had specifically defined pathways. Well, now that we're packet switched, I can send it any direction I want to, within reason. I still need to get it and reassemble it in the right order and in a timely fashion. And so that's where we get that prioritization so that we can get it very, very quickly. So when I had a circuit switch network and I picked up the phone, and if you just sat there and you didn't speak at all, so it was your parents calling and saying, "Why did you spend all the money at the bar last week?" And you just had that blank look, and you're on the phone for silence for 30 seconds, that connection still had to be open. Packet switched, it's going to go, "Oh, that's silence, sending a packet. Nope, nope, nope. Now we're going to send one because you finally had some voice." So what we're moving to then is what we're going to call unified communications. So now, not only can I make a voice phone call, but I can get on the web. I can send what we used to call faxes. Now we're really just they're scanning pictures. We can do things like voicemail, locations, and even phone calls. So no longer do I have to be tied down to my desk. And so when I talk about how our phone system on our campus is really antiquated, we don't have anything like a unified communication system. Some of the really sophisticated ones, you wear a little badge like you did in Star Trek, and not only will that badge work as your phone, but it also tracks your location. So if somebody comes in and they call you, it will track down to the nearest phone, and you can actually switch over to a handheld phone so you're not on a speakerphone. It will track your location, so if I'm not at my desk, maybe we all have a chat messaging client on there, and it will actually say away from your desk. So we start to bundle all these things together. Now we've got video in there. And the video calls are really great because when we get that extra information, it's not quite the same as still being there in person. But when you send a voice call, or you send a text message, or you send an email, you lose out on a lot of that connection. And so if you can actually see somebody, so imagine trying to buy a car over the phone and not being able to look in that car salesman's eye to see how bad they're lying to you about a price. And now picture at least, hey, I can at least get a video call. So we're working towards this idea of unifying all these pieces together into one big communications method. And so it's one area we don't have much at all, if anything, on our campus. So once we put that together, we don't care what kind of network it goes over. We could care less. So it could go over a cell tower. It could go over a Wi-Fi. It could go over a wired connection. It could go over fiber. We don't care once we have that unified communications piece. So one of the most common, and the one that has changed business the most so far, has been something called VoIP, Voice over Internet Protocol. So behind the scene, your calls are already over Internet Protocol. You just don't know it. But now we're able to put these calls out, and we're able to do it cheaply because we can carry it over any network. We don't have to pay a huge amount per minute. We can send them on over anything. So I can plug in my Skype phone anywhere I have internet connection, and great, I can make a Skype call, and nobody has to know any different. So we can carry it on almost anything, and that's where it becomes interesting, and it's scary to the phone companies. So I've used this as an example before, but at the hospital in Falls City, when I was there in 2009, when they built the new facility there, or the newer one, it was going to be over $250,000 for a phone system. They ended up moving the old one, and paying people a huge amount of money overnight to set that up. When they replaced it last year, it was down to $60,000 because of VoIP, quite frankly. It's carried over the same network that all the computer signals are carried. And when it leaves the hospital, its traffic is a lot cheaper, so they cut their long distance bill down significantly. And so in terms of a business, this is a great model. It has cut the cost of business significantly for anybody that uses phone calls. It has also set up the world where you don't have to be in a physical location. If it weren't for VoIP, things like being able to route your calls to your house, so companies like Apple couldn't have their text setting at home. So it enables that. So it's a great technology. It also allows us to have customer service centers in countries around the world, and sometimes it presents problems because we can't understand them. But again, it sets up that model that we're able to use. So VoIP has really been a game changer in the world of what's happening in the network. And so if you're working with a business and they're not looking at running VoIP for a phone system, if they're going to upgrade, or even if they are just looking at it, how do I save money? And quite frankly, it's something that's frustrated me about our school is we haven't ever really approached this. So, lower cost per call, more features. I could be at home and the phone calls could roll into my office at home or on my cell phone or wherever I happen to be, and as a student calling in, you wouldn't know any different. Right now, we have an antiquated system where we finally turned off voicemail for most of us because it was so ineffective. So now if you call my office, and after 5 rings or whatever it is, it goes back to the business office and they'll hand scribble down a message. Yikes. So, how do we deal with this idea of this voice and data all converging into one? So, there's a lot of pieces to it, but there's some that are very common. So we can use a lot of our existing technology. So our old phone lines in the building, we can, in fact, sometimes we even connect our old phones using a telephone adapter. We may have to add a gateway capable of sending those. And we probably need some kind of a PBX system. And here we have an old PBX system on our campus. There are even open source efforts in the phone system. So there is an open source digital phone system called Asterisk that actually is the backbone of a lot of paid for systems. And then we have to think about, do we have an IP phone? Do we have a soft phone? So in a lot of businesses, you don't even have a phone anymore. You just have a headset connected to your computer, and that actually is your phone. And there are services. So one of the most common is something called Skype. We're going to actually investigate another one called Viber. There's WhatsApp. There's tons of different apps out there if you want to communicate. And if you are, for example, an international student, it used to be very expensive to call from one country to another. And that's no longer the case. If you both have a Skype account, you can connect for free based on just having connections back and forth. So, we'll finish up this piece on Wednesday. In our assignment for this week, so there's a couple of assignments. So this one says we're going to work with something called Viber, and you're going to look out on Wireshark and see what it does. You also have an exam, and then a discussion board. So week 13 in the discussion board. Yep. So week 13 says there's a backup project, complete and post your results. So again, we need to reply to 2 students. The assignment isn't horrible, but you will need to use that Wireshark that you've installed previously. And then one thing I want to throw out is, if you haven't enrolled, get there. Please. It really does benefit us all so we can plan better. And it avoids those, I really should graduate, but I have one class I haven't taken and there's no openings in it. And it's only taught in the spring. Guess we'll see you around here next spring. So those moments are always sad. All right. Pause here if I can find it.